Hello, everybody. This is the Enterprise AI virtual user group, and today we have our expert panel, Enterprise AI panel of experts, and we have a few people here that are our experts. So let's go quickly and make a round, and please each of you introduce yourself. Let's start with Mani.
All right. Thank you, Eyal. I don't know if you can see my title, but I'm a freelance developer. I have a long title, but let's leave it to freelance developer. I work with Java and also recently with Python, and I've been in the software engineering for 20 odd years now. And Java has been maybe more than 1/3 or maybe 2/5 of it, whichever way you want to look at it. What do I do in my day job? I work with small startups and small teams and help them accelerate in their software engineering, data, and machine learning processes. And in my free time, I do more or less a lot of open source work, which spans anywhere from Java to Python to writing blogs or presenting like this or giving a formal talk. And lately, I've been working a lot with Java and AI and also overlapping a lot of my Python work with it. So looking forward to the rest of this session, where I will be speaking with all of the other colleagues here. Thank you.
Thank you, Mani. Let's continue with Adam.
Thanks, Eyal. So I'm Adam Polcock. I'm an ML researcher. I finished a PhD in machine learning 8 or 9 years ago. And I work in Oracle Labs in the machine learning research group. So I write papers on machine learning. I build prototypes and help collaborate with internal product groups at Oracle. And last year, our group open sourced a Java machine learning library called Tribuo. And I also do quite a bit of, sort of open source Java work in machine learning. So I'm a member of the TensorFlow Java special interest group who developed TensorFlow Java bindings. And I wrote the Java bindings for the Onyx Runtime to allow you to deploy sort of Onyx models, which includes like Python scikit-learn things on JVM.
Thanks. Let's continue.
Hello, everyone. It's good to be back here. I work as a cloud advocate, developer advocate at Oracle, and in my job, Java has been with me. I'm wearing Java hat for many years, since almost beginning of my career. So I always loved working on Java in various ways, from enterprise projects, Java EE apps to these cloud native microservice type Java frameworks. And in this group, Java frameworks for doing machine learning. And I like to play with them, prototype, write some blogs, give some talks around those, teach others about that. And here we are to talk about more of that and anything that audience would like to ask.
Thank you. And let's continue with Zoran.
Thank you, Eyal. I'm Zoran. I'm teaching software engineering and AI at University of Belgrade, and I'm working on a Java engine for deep learning deep nets, which is suitable for the beginners and people making first steps to the deep learning world. Previously, I've been involved in a lot in open source world and Java. I'm a Java champion, member of NetBeans community, and created a very popular open source library Neuroph, which was like a very nice educational tool for neural networks. And now deep nets is something that I'm working on, and collaborating also with everybody in Java community to build a better support for machine learning and AI for Java. And also part of those activities is working at JSR within JCP for the visual recognition API based on machine learning. So looking forward to your questions and hope make Java more popular into machine learning world. Thank you.
Thank you. And I'm Eyal. I run this Enterprise AI virtual user group. And I also run the local Jacksonville, Florida Java user group for many years. So I've been a Java developer for many years. I have done research in AI many years ago and then continued with it as a hobby. I now write a blog called AI for Java. I will show it a little later. I mentor Java developers, help them get started with AI and machine learning, and sometimes also help companies implement AI in Java, where most of what's available seems to be Python, but there are ways to do it with Java. So thanks to the other guys here, I can actually usually find solutions in Java for companies that want to continue with just using Java. So we received a few questions that I put in the live chat, and you guys are welcome to add more questions to the chat as we keep going, or to the Q&A. There is a questions tab. You can also hit the emoji button down there just to, for example, to show us that that you can see us, or that you like what we said, or something like that. So I'm just demonstrating it here. Shall I read the questions perhaps now, perhaps, so we can also talk to them as we go, or perhaps we will do first a round of. Let's do that first. Let's go back through everybody, and you guys can each tell us what currently you're doing, what is later that you're doing, etc., what you want to share, and then we will get to the questions. So let's go the same order, starting with.
Okay, so currently I'm working with two different types of data sets. I have been doing some Java stuff just recently, and I think given a talk on this channel not really a month ago. There's a bit of a pause there, but what I'm currently doing is I'm working on a data set that is a very simple data set. It's a regression problem, but I'm trying to do it very differently. I'm trying to use a combination of tools like AutoML, techniques like clustering, and high dimensionality reduction techniques as well, to get different aspects of and understand the different aspects of the data set, and then build my machine learning model based on that. So in between, I am also switching between EDAs, and that is helping me build some sort of a tool or a library or framework, whatever you want to call it, that I can then use it for other data sets. So I'm trying to make it more generalized. I don't know if I'll ever make a library, open source, or framework out of it, but this is for more for my personal musings and understanding of data sets. And I usually get these kinds of data sets now and then. So the second kind of data set is also a regression problem, but it's lots more columns, and it's a lot more harder data set because of the signals in there are very, very low. But I'm switching between these two data sets and using the library that I wrote, and I'm encapsulating that library with an AutoML tool, which I'm constantly tweaking. So I think the other day when I spoke to Eyal, I was mentioning to him how I can write some sort of a hyperparameters layer that will search for the best parameters I need to pass to this AutoML tool to get the best results from the data in the data set. And eventually I have plans to include other libraries like Tribuo and deep nets into the loop. But I want to first make this work with a very simple use case. There are going to be problems with it, and hopefully that'll help me learn. So it's not a Java solution, but it's a solution that is a more open solution that will be able to incorporate Python and non-Python and Java and non-Java technologies in it, hopefully. And someday I will be able to show it here. Maybe next time when we talk, I could give a little bit of a preview of what the data sets look like when I analyze them. Because I've also done visualization. Like, what people don't do is every time you generate an inference from your model, don't compare that with all the other inferences in the form of a correlation matrix. And that is really useful to actually, even though your metrics might tell you some score about your data set, but to see all of them across each other, you get a very nice correlation matrix, which again, I can show the next time. These are all a lot of experimental, so I'm not saying I'm an expert in it and this is how you got to do it, but it's something we can all look at and discuss and maybe improve. So that's kind of what I'm working on currently. A little bit abstract, but hopefully I'll be able to share more practical aspects of it in the next session.
Okay, that would be great to see. Let's continue with Adam.
So recently, TensorFlow Java had its most recent release that's based on top of upstream TensorFlow 2.4.1. I posted a link in the chat, which I think people can see. So that the TensorFlow Java API was lacking in development for several years and is now receiving quite a bit more development. So we're going through and trying to make it more idiomatically Java and expanding the set of things you can do Past couple of releases have added support for training, and we're building up like higher level APIs of the kind that's present in TensorFlow 2 in Python. We're still working on that. If anyone wants to come help us, that would be super great. Otherwise, we'll get there. There's a lot to build. Aside from the Java release, the TF Java release, we're building the next version of Tribuo, the next feature release. Pretty much everything is ready for that, apart from the integrated TensorFlow support, which had to wait until the 0.3 release, which I am currently finishing up.
Perhaps just mention what Tribuo is.
Yes, sorry. So Tribuo is a single node Java machine learning library, right? Java has pretty good machine learning libraries in Spark for distributed systems, but there isn't really anything that kind of meets the same need as scikit-learn under a friendly license. So Tribuo is supposed to be that. We also have a very strong focus on provenance. So we record model training, so everything's perfectly replicable. If you have a model, the model contains the recipe to rebuild itself if you have the same data, which is useful for sort of ensuring your experiments behave themselves when you repeat them. And it also has a much more object-oriented interface because that's easier to integrate into upstream applications. And then aside from that, the other thing was the Onyx Runtime, which has the Java API that had its most recent release. The Java API integrated a while ago. This release catches up with the features available in C and C#. Python is a little further ahead due to the way that things are integrated. This one mainly has things for threading, which tends to be pretty important when you're deploying this in some sort of container. So we've added better controls for that.
So Onyx is a way to
yes, sorry. So yes, sorry. So Onyx is the Open Neural Network Exchange map. It can be exported to from a large number of different libraries. So you can export to it from things like libsvm, scikit-learn, PyTorch, TensorFlow, XGBoost, like a large collection of popular machine libraries can export into Onyx. Tribuo can't yet, but it will do. And then the Onyx Runtime allows you to score those models and deploy them under a variety of different languages. So there's a C interface, a C# interface, a Python, the Java one. I think there's Node as well. I haven't paid too much attention to that, but I think it exists. And we use the Onyx Runtime in Tribuo to provide support for that kind of model as well. So that's a bit. Apart from that, I've mainly been focusing on getting large sort of NLP transformer models, BERT models, up and running in Java, which will land in Tribuo, although there are a few other ways of doing this in Java, depending on what your backend system is. I think DJL and Spark NLP both support it.
Thank you. So Adam is the one that's actually involved in actually creating Java libraries and tools that are official tools. And it looks like we see you much better now. We got focus, but at the same time we lost Zoran, so I hope he rejoins. And let's continue with Suyal.
So on my side, attended various events this month and previously. This month was a big release for us at Oracle with the new Java release. You know, it's Java's community project, but a lot of people at Oracle work on it. So JDK or Java 16 came out, and we can maybe talk. I'll put some question maybe for Adam, because there is one feature in that can maybe potentially help with some kind of deep learning with Java. But that was exciting, and we had a lot of hands-on labs, free. We call it Oracle Developer Live, and it's free event. And so I attended a lab around GraalVM, and got me thinking, because GraalVM is this virtual machine which can run not only Java but other languages as well. And maybe could we do something like, because it has a GraalVM repo. I played with it. It has a example. Java code can call Python code, and both are running on top of GraalVM. But can it do machine learning in Python and have Java app use that some way? don't know. That would be an interesting experiment to do. That's something on my list. I actually opened an issue on the GraalVM repo because I ran into some problem with that. But I got a response back quickly from the GraalVM folks as well. Other than that, I have been trying to make a chatbot. So think of like Amazon Alexa, a voice bot. So, but Alexa, but your own Alexa. So something I got this thing. This is a Raspberry Pi, and Raspberry Pi is mounted on a display, and the display is like a touch screen, 7 inches, a nice touch screen. Because when you work on these things, you want to see what's happening, and you can see it through, remotely connecting, or you can actually see it if you have a screen. And I was thinking, then there is a thing called Pi camera, small camera, and mount that, and then that can be connected to the Raspberry Pi, and then can we do little machine learning using the frameworks we have talked about on the Raspberry Pi. And it's very much possible in the Python world with this thing called TensorFlow Lite. And I've been trying to see if I could do that with the Java version of TensorFlow Lite, because Google has made TensorFlow Lite, for Android, iOS, Raspberry Pi, many things. And Java 1 was made mainly for Android, but it also exists, and I haven't reused that, but it makes the model, reconfigure the model to be much optimized to run on small devices. So idea would be to just simply recognize playing cards. So when the camera sees this, it would create a bounding box, and it would put the label and the probability. Simple example, but I want to show the whole end-to-end process of taking pictures of these, modifying them, training them, and then deploying it, and then run on the Pi. And then if that can be done, then I can do some cool magic tricks, or this thing can do magic trick with the audience. It can talk to you, and it can ask you to think of a card and show it, and it can fun little things. And the code I'm writing, it is in the UI for that is in Java and Java FX and Java, and then other Java frameworks for doing, just kind of doing recognition, and there are old school framework to do that. There's a Sphinx library by CMU, but I'm trying to see if I can leverage Python and Java together somehow. Would open up a lot of possibilities, because honestly, there are more advanced speech recognition, speech synthesis projects right now in the Python world, and the Java world has become a little bit behind. So yeah, that's it.
Thank you. So I think Zoran might actually, he told us in advance that he may have to leave at some point, so he may not be coming back. So let me tell you a little bit about what I've done recently, or it's not just recently, but let me share screen, and let's see if that works. And let's do that. So first of all, I have this blog called AI4Java.com, and can you see my screen? Can you see it coming up slowly?
Yeah.
Yeah, we can see your screen.
If you go there, you can basically register and become part of my community, where you will get emails from me, and you can also not do that. You can bypass that and just go directly to what you see on the right side, and you see that right now there are two modules. Each one of them teaches you some AI or machine learning. At this point, it's pretty much machine learning. So the first one gives an introduction to supervised learning, and then continues towards a neural network and deep learning for J, which is something I've done a while ago. Meanwhile, we have some other competitors to deep learning for J, but same principles. What I've done more recently is machine learning implementation using Java and Tribuo, which is the framework that Adam has been working on, and with his support, I was also able to learn this framework sort of as soon as it came out, and then write a few blogs on it. So you have 4 posts here that go there, you just see them all in the right order. And in the last of the posts, I try to build it up in sort of stages, but the last post actually shows you how to build a REST service that predicts the quality of wine. After it basically in the previous in the post second and third, I train a model on a data set that's available that has information about wine and the quality of the. So at that last post, I take Spring Boot. I take the framework of Spring Boot, just use it to create a very simple REST service. And the REST service uses that model that was saved, it brings it up from the disk, and it will respond with the predictions. So I can maybe run it now. It's sort of simple. So I have it here in Eclipse. Can you see that? Now I'm going to run it. So when it runs, you will hopefully see that it's a Spring Boot coming up. It takes a few seconds, or maybe it's... and once it's up, you can actually see when it's the model. You will see in a second that I think my computer is very slow now because of that conference call that we have. But what it does here, by the way, is printing out this provenance that Adam was mentioning. So it reads the model, and the model actually has inside of it all the information about the data set that it used that the model was trained on, all kind of information, and then all the information that was used during the training process, kind of a model it is, but it's a random forest and all the parameters. Once it's up, I just bring it to the screen so you can look at it. It's not necessarily, it's not needed unless you want to verify perhaps that you got the model and it was the same data that you're going to now serve is the data that you had in mind. But once it's up, I have your Postman, so I can send requests to that application. It's local, so it's right here, but I can say predict 150, and I have a controller that is it's a class that will basically take this, feed it to the model, and send me back the response from the model. So these are the features that this model can accept. So the request has the value for each feature, and if I send it, it will send me back the predicted quality, and that's what you see here. So this is a very simple demo, but it basically shows you how many of the real-life models are working as you put them on a server, and they return the response, and then you decouple. Basically, you present to the world this interface, and they don't have to know the details of the model, how you trained it, and when you replace it, and etc. So I think I can stop sharing now. Going back to the conversation, if anybody else wants to, I'll just put here ai4java.com so you can look at that. I have a few more links. Actually, let me show one more link. At some point, I created a book. Okay, to share again, I'm sorry. There is a series of books that's called the low-hanging books, which give you a very small amount of information that should have a big impact on you if you're starting with something. So let me find it. So it's called lowhangingbook.com is where you can find all these books. So I'll put it there in our chat. And there are books in different subjects, but mine is the last one, and it's called the Low-Hanging Machine Learning for Java Developers. So it actually shows you 3 tools that are very easy to get started with. One of them is the tool that Zoran mentioned. He created the that is called DeepNets, and it has an IDE that has all kind of wizards that if you just want to play around or also create actual applications, it's a very good way to get started and understand how neural networks work. If you download this book, if you follow this link, you will download the book, and it will also join you to that AI4Java mailing list that I mentioned before, and you will start getting those posts or packages, modules as they come out. So we can now perhaps talk about, anybody else wants to comment on anything, or shall we go look at the questions that we have?
I just wanted to add something to what Suyash mentioned earlier. I don't know if everybody's reading the chat, but he's been playing with Graal VM recently, and myself and Adam has already done this. We've been looking into Graal VM. I mean, started looking at it since 2017, 2018, and it's come a long way. And you can now run Python on the Graal VM. So the Python that you run using interpreter Python. Of course, Python has got lots of tangents and varieties and forks. So not everything in the Python world works there, but a lot of the simple things work. I don't want to say or comment on how far things work and don't work, but it's still work in progress. But which also shows that as and when this becomes more mature, we could have a lot of the Python libraries and a lot of the Python work, a lot of Python notebooks that we have written that work in the machine learning world and the scientific and mathematics work will start now running on Graal Python. And because Graal Python now runs on the JVM, it already gets that extra boost in terms of speed and all the other benefits that the JVM comes with. So, and then we also have native image. Eventually, hopefully, we will also be able to compile some of those non-Java binaries into native binary, and then maybe we can run it on the Raspberry Pi without having to go through all loops of TensorFlow Lite and all the other things we got to do. And that would be something to do. Even without that, I was saying that we could actually run a lot of Tribuo examples, compile them into, and I've already compiled them into binaries, which you can see on the link that I shared, and run them on the Raspberry Pi, because Tribuo compiles into pure Java jars, and those Java jars can be compiled into native image, and those native images can be as small as 20 megabytes, because we also have something called UPX. I don't know if you guys are aware of it. It compresses executable files, whether it's Windows, Linux, or Mac, and it'll bring it down to almost 50 to 60% of its original size. So if you have a 100 megabyte binary, you can probably bring it down to 40 megabytes, maybe 50 megabytes. And then some of that, and also it loads up very fast when you do that into memory. And so those are all those areas we could explore in terms of running things on edge devices or machines with low resources, or even on as microservices on cloud as containers or virtual machines. I don't know if it fully answers your question, Suyash, but it's something we could explore and maybe come up with an example where people can do that.
So Graal VM will also enable us to have Python programs work with Java programs in cooperation?
Well, Graal VM, yes. So we already have multiple things in Graal VM at the moment. There's a polyglot mode where you take a piece of Python code and you paste it into a Java function. It'll run it in the background, run it on the Graal Python interpreter and give you the results. So that's the current phase of things. But I'm thinking that this could further, that you're not doing it this way, but you're actually compiling it using a general compiler, just like you have Javac, which will compile the Python file, and you get a jar file from it. And yes, interop is possible, because then from Python you can pass on your object to a Java app as well. In the same way, you load up a Java class where you actually run Python, and then whatever results you get, you can pass it on to another class which actually accepts the results from the previous one. And everything is basically embedded in Java. So under the hood, it's still all Java, except when it compiles and interprets, it's moving on to the truffle world, doing the work there, and coming back into the Java world. You're saying something, Suyash?
Yeah, like how about performance critical workload? Like, let's say, so if you have a thing like Alexa or Google Home or this thing I'm trying to make, it has to have a model that's always there, and it's listening for what they call the wake word. And it's pretty simple to train a model for a wake word, like particular words. But in Java, programming, you would create a new thread, and that thread would handle that, listening, doing speech recognition, and then the other main thread can render UI or do other kind of things. So when you have something like this, like let's say in Python, because Python, they have a better speech recognition library it's very simple to use. Do you know if in Graal it would be possible to have something, calling the Python code in a separate thread, so that it can continue to run the speech recognition, in the background?
So even without Graal VM, you could do it now with Java, and you could do the pure shell call. So then you have the best of both worlds. Of course, whenever you have multiple abstractions, you've got all the delays in between. But let's say, and I always do this with everything, is you have a Java application, you make it multi-threaded, and then you convert it into a native image, a pure native image, which means it's a binary. There's no Java required there. It is multi-threaded. And now that calls the Python application in the way it would call, using processes or whatever, or Panama interrupts or whatever. And there will be a delay, but the Java app will run so fast. It'll run much faster than it would be running on the JVM. It's actually arguable. Sometimes on the JVM mode on Graal VM, it could run faster than it would run in the native image mode. But those are different discussions. And then when whatever you want to do, because you want to do something very simple, right? Listen to only a handful of keywords, right? You're not listening to the whole dictionary. And those handful of keywords will have a fixed model, right? You won't have, those models will not change rapidly. So now, once you have all of this, in fact, you may, I don't know if that, we'll have to look into the implementation, but you could have your Java app call the Python app, which then calls the model, right? And if we can abstract out the Python app's functionalities, given Tribuo is increasing in functionality, and there are some other Java libraries as well. Hopefully Zoran will help us with more stuff. We could bring those abstractions to a Java layer and not use the library at all till we actually really need the library, right? Because we can bring in the simple things into the Java world, and we can still use the same model because the model binary will not need to be changed, right? And then slowly we need very, very simple basic things, right? We just need the model. We just need this functionality that depends on calling that, mapping that keyword to the thing in the model. And then you have a multi-threaded Java app, which is native image binary, which listens for that word and passes it on to this model and returns it back. So, and then the model itself should be like a compressed model, like a sparsified, pruned model. And of course, that's something we can learn how to do. There are tools in the TensorFlow world to do that. It all depends now how we build the model from the library. Right. So this is kind of more like a very hand-wavy explanation of how we go about doing it. Of course, when we start looking at the solutions, we'll have to come up with more specific questions, and then refer to experts like Eyal and Adam and Zoran for help. But this is more or less how I would go with it. So it's possible to do it, and then you don't even need Graal VM, because once you have the native image, it works on its own.
Yeah, I like the Graal actually, because the way I think I was overcomplicating it, I was thinking the Java code calls Python code before it's interpreted, before it's just like in Graal VM, like you actually call it as if it's another class, and it does its thing. But there is a simpler way, like you said. Like I think it can invoke a shell command.
Exactly.
And that could be the Python program.
Exactly. And that's a very poor man's way of doing it. And I'm sure Adam has done this using his interrupts and Panama libraries, and those are faster way of doing. So you bypass a bit of Python's slower infrastructure and go right to the meat of where the call needs to go to. I haven't done that.
Adam or Eyal think about it?
Yeah, I think we might want to pull them for their expertise.
I mean, I have used Python interop. I did use it with shell calls. I wrote a hyperparameter optimization system that could optimize Java or Python things. It was rather ugly. Used a bunch of Java technologies which are now quite deprecated, but it worked. The difficulty is how big the thing you have to pass across the language boundary. In Graal VM, because everything's in a shared virtual machine image, it's all in the same memory space, that cost is much lower. If you have to go through a shell call, you have to pass it through a pipe. It has to leave one process and go into another process, and you pay a lot more memory costs. So it kind of depends how fast you need to be. Or you can have the Python process a REST endpoint and talk to it that way, but you're still inducing a REST call locally, which is weird. It's doable. It's a lot more complicated. I think the Graal VM path is a good one, as Manny said earlier. They're still building out the support for everything. It supports many things in Python, but not as many of the machine learning bits as you would like it to at the moment. They're still working on it, right? It's still not production ready.
Cool.
So
talking about it, going the Graal VM route is a halfway house between doing the shell call or doing Panama or doing it another way. And so you may get a little bit on cost in performance because it's still running on the JVM and it's still running on a framework called Truffle. So that kind of slows it slightly down. But in the long haul, when all of those speeds up, your applications are going to run faster. Also, the other thing is there's a little bit of a hitch here. The native image bit I was talking about is purely Java JVM bytecode code that it can convert native image to at the moment. But I don't see a reason, and I've already discussed this with the experts, and of course they haven't committed anything. But I don't see a reason why things running in the Truffle world cannot be converted into binary. Of course, they were talking about things that JavaScript does and the JavaScript interpreter does that makes it hard to convert a lot of that code into native image. But that's not necessarily true for all the languages, right? For there could be languages that are easier to convert into native image because all of this is still running in the Java world. Even though they're interpreting Python code, there is no more Python involved there. It's just the language is just used as a way scaffolding to run the code. But that's my understanding. So as things get better and we can convert polyglot applications into native images, so then you can convert all of your Python stuff into a native image, and then it's not going outside the boundaries of Java. Then it's all in the same heap and data space, right? So then we have the extra thing, and that's the benefit you would get by doing things in the Graal Python world, as opposed to doing half Java and calling using all the different things Adam named, including bindings and shell call. I mean, shell call is a great way to start to get your prototype working, and then slowly you keep replacing the different scaffoldings with better bindings, and eventually replace all of that with Graal or anything else that comes out before that.
So Adam needs to leave soon. Let's maybe give him a chance to answer any of the questions that were asked. Do you want to address any of them in particular?
So I'm an ML researcher, so I don't actually know much about writing web tools. So I'll leave those for the other people who are more familiar with those. But there was a point here about Java AI development and doing work in Python versus in Java. So I do have something to so that one, I write a lot of Java libraries. I also write quite a bit of Python code because at the moment the Java ecosystem doesn't cope as well with doing the research code, right? And so the frontier of machine learning and natural language processing are going away at some speed, right? The field is expanding quite a lot, and getting the forefront of the research into Java to implement it is a bit harder at the moment because the research code keeps building upon itself and it doesn't get ported. You have to bring it over to a different system. So I write Python code for some of the further off research things that I do, and I write Java code when I tend to get it deployed. You can write research machine learning code in Java. We have published papers that were entirely written on Java code bases, and it says in the paper usually. So you can entirely do that, but the papers that Google release, they release a Python implementation, and so if I need to compare that, I have to be in Python to do so. So that's where I end up doing it. Not as much for deployment, but more for research.
Do you have anything you can say about quantum computing?
No, although I think that the JavaFX people, one of those guys is very interested in quantum computing, right?
Right.
Johan Voss, I think.
He wrote a blog, yeah. But.
Yeah. Spark, I think, is widely used. Spark MLlib is something that I have used for machine learning for many years, on and off, when I have problems that are large enough to need it. And there's Spark NLP. I was recently talking to the developers of that. That's got a pile of technology in there. And lots of the other Java libraries have integrations with Spark to scale them up. So Spark is still quite a popular technology.
Yeah, there is a framework, other framework, forget the name. It's for deploying, for monitoring models. Came out of Databricks. I forget what the name is, but it's
ML Flow, you mean?
ML Flow in Java. Yeah.
ML Flow, yeah. There's weights and biases as well, and they have weights and biases beginning to start with their work in Java. So they'll have a Java client that you can use to. Yeah, it's very early stages. So basically, the Java client is a bit of a wrapper around their Python client, but actually they're talking to their API. They're talking to their server using Java API. So that'll be interesting to see when they're ready.
So I understand that Adam is going to leave any minute now, so do it at your convenience. You can stay as long as you want. I'm just preparing.
Yeah, I can quickly answer the question I made. I have to leave also. EL, if you want to formally close, we can close at 11 or, well, I think more people should ask their question on chat if they have anything. I think there's already people have conversation.
Okay, I can stay a few more minutes, but I'm not sure how much answers I can give. So why don't you answer any question that you would like to from the list that we saw?
One question that was popped up was, is there any study on how much Java versus Python is used in ML? I don't know of any study, but from what I've heard from many companies, including Oracle, in enterprise generally, a lot of the big software apps are written heavily in Java. And so when companies want to leverage machine learning, they machine learning has many libraries that people want to use, and they are in Python. But slowly and steadily, there's a lot of progress being made in Java, as you probably heard today in this chat. And some of that motivation came from companies like Amazon created DJL, from what I heard from the folks who work there. It's an open source project out of Amazon, because a lot of Amazon code is written in Java, and they wanted ML work to help their Java engineers. And so they created this, and they open sourced it. Same thing, Adam can speak more about it. He knows firsthand, but a lot of products in our company use Tribuo, machine learning library that Adam leads. And because the code is written in Java, and Tribuo is a Java library. So there is, in the industry, there is a lot of adoption. Netflix is another big user of various deep learning Java libraries. And the more people know about it, more people share the word, like you guys here, or put a blog post. Half the problem is people don't know all these libraries in Java. They're modern ML libraries, and modern ML tools like Onyx that can help you bring your models in from different frameworks that are Python based. So yeah, there's a lot of exciting work. That's all I would say on that point.
See, Adam. I could add a few things from that question, if I may, EL. So I won't go by jab, but like some of the things that I pick up from here is, so as a Java developer, and at least in today's time, and I don't know when it started, but since a few years, I already started feeling I'm a polyglot developer. I'm no longer just a Java developer. So seeing that, I'm a Java developer. Do I need to do this in another language? You actually, on a day-to-day basis, you're constantly switching between different languages. You're using a shell script. You're using, JavaScript. You're using TypeScript. Even if you're not a front-end developer, you're doing a lot of things. You might be even using HTML. And as a developer, you're going to switch between all of these languages. And there's things written in Ruby if you're doing a lot of DevOps stuff. Things are written in Go and Rust. And so, and I use Python a lot recently because I've also got more familiar with it. Because a lot of times I want to express things really, really quickly. And I can do that in Python and then bring it into Java. So I can prototype it in Python because it's really, really easy to quickly to do it. Like EL has been there a month ago when I gave a talk. It was on Tribuo and DeepNets. Both are purely Java-based libraries. But I wanted to show an ensembling example. So I could do that in Java. It would have taken me a longer time because some of the things I had to build from scratch. But in Python, some of those things are already there. And I already had code that I could actually just copy-paste, modify it a little bit, and adjust it to the needs. So I saved a lot of time. I communicated my point, and we have a working a semi-working program that is on GitHub that people can use and translate to the language of their choice. And so, and my personal plans are also to translate and transform that from what I've written in Java written in Python into Java. So that kind of hopefully answers your question. Like as a Java developer, as Java AI developer, or a data scientist, or a machine learning engineer, they're using Java or not, it's going to become more and more secondary. You're going to be jumping and switching between lots of different languages, just as you switch between lots of different frameworks. We use TensorFlow, we use PyTorch, we use another library, and hopefully that answers the question. And I did share a couple of links on quantum computing and Java's contribution to it. And if you also go to my GitHub repository, which I shared, it's called Awesome AI ML DL. I think I've shared them earlier. And there's also an Awesome Graph library repository. All of these repositories have more or less answers to questions about AI and Java. And some of them might even have links to quantum in Java or just quantum computing on its own. So that'll be like the shortest answer I could give for that question, because I mean, there's a lot that can be talked about it. And as Suhash was mentioning, it's firstly, people don't know about it. So we then go to the effort of putting libraries, repositories like this, where we host all of this, so everybody can get access to it. And yeah, I'll see the same answer to what Suhash mentioned about there is no study done. Java started off a little bit later, but it's not to say that it started off later, because we, EL and myself, have come across libraries in Java that have been written some time back that we're still using now, like Apache OpenNLP and Mallet. They have stopped developing in those libraries, but they have been written pretty much around the same time the Python community started developing their libraries. It's just because it got stagnated and it didn't get progressed any further. There is also one more question, I think. That was a fifth question. Is AI currently prevalent in web browser, or does the panel see a trend for what's happening? So if you follow WebAssembly, and then if you follow GraalVM, so you can now run and compile WASM on GraalVM. There's GraalVASM layer that you want to look into. Again, I could share the link here, but if you go to the Awesome Graal repo, you find everything on WebAssembly and those kinds of things. What I will do is I will share the repo again, just in case somebody has missed it out. And that should answer your question. I'm going to just do a reply on that question. So,
just to add to that, there are JavaScript libraries now that are also available for even TensorFlow for JavaScript that enable you to actually put stuff at the edge on the browser. And that, in some cases, it solves issues of privacy because you don't want to send the information to the server.
Yeah, and I may put a thing in the chat that there is one awareness problem people don't know, because once you realize that you can do pretty much everything that you can do in TensorFlow and Python and Java, that's what these people are working on. TensorFlow for Java, the project is called. It currently has support for inference of the model, so the second half, not the training. So one could train the model in Python, or your data scientist can do that, and you can, very simple to plug this library. If you use Gradle or Maven, you just have to add the dependency, and then you port that classes and you call whatever the API is that take this model and do the inference, and then you pass in your data set. So my card example could be my IP images or whatever, somewhere camera up, live feed, and then your project Java. So now you don't have to juggle. But there is also the bigger trend happening in the industry called microservices, which has made, in earlier days, I remember we used to check out an SVN, a big giant Java project, Java E application, and I would touch like few classes there, and somebody else would do the other work, and nobody has full knowledge. And in that case, it becomes more important to everybody's working in Java, because our dependencies, the jar files, are in this big giant monolithic repo project. But with microservices, now teams are, like Manny said, if they think the best use is Scala, and they're using Scala like a Twitter for something, Java for certain, Ruby for job, and they are all talking to in this bigger Twitter.com app through REST endpoints to each other. And because these are now small projects and then using cloud and various architecture, so that has also created an opening for using whatever team wants to use what platform. So there's various things happening. You have to really think about it and see the pros and cons. But both languages can win. Yeah, it's battle anymore like old days.
Yeah, so there's the other kind of a misunderstanding also that, can I do this in Java? Now, Java is a tool. You can do pretty much everything in Java. And there's a lot of AI work done in Java. Like if you see some of the work done with Apache Spark and also a lot of the Python work cannot scale after a certain extent. It's not multi-threaded. It's not robust like a lot of the Java applications. So there'll come a time where you have to wrap a lot of those Python work around Java to make it run at scale. And so eventually that wrapping Java around Python might start becoming a bane instead of a boon. And you'll have issues with that. So I see a lot of this work that is great work that's done in Python and R and MATLAB and all the other things, slowly bits and pieces of it getting migrated into Java because Java is a lot more solid. It's a lot more stable, a lot more reliable. And when it comes to multi-threaded and processing at scale, running on the cloud, it is already a tried and tested tool in a platform. Unlike Python, which scales up to a certain extent, but then it has to take help of other solid, robust tools. I don't know about R, MATLAB, if that ever has been put into production at scale. But that's my experience and my view on things. I think Eyal wants to say something, and I'm actually not giving him a chance.
Well, I think Suyash sort of answer in the chat in a manner. I think where companies realize that the Python is a problem when they don't just look at the writing the code, but when they look at the DevOps. Now they have to create a whole system or platform to start doing the compilation and deployment and integration, and they cannot usually do it at the same time for both languages. They will have to build this separately, and that's a large cost and effort and time. So that is another way to tell management, consider that before you just decide let's do this in Python, let's do that in Java, and productize both.
Exactly.
See companies that they want to develop a machine learning project of some sort, and they're a Java company, so at least in some cases, they would go to university, they would work with students, or even hire data scientists. They're all doing it in Python, of course. And like was mentioned before, these students or scientists can build a prototype that says, okay, this is how we approach the problem. These are the features that we are extracting. This is how we process the data. And this is the type of model that is the best. And then they will go and find a way to implement it in Java in their code to productize it, because that's what actually goes into the production is Java. And the Java frameworks we mentioned are ways for them to do that. It's sometimes challenging if it's a niche, especially if it's some kind of niche, that because Python is faster to respond to this. But in mainstream machine learning, which is the usual case, you can do that in Java. You can find a way to transfer what you prototyped in Python, transfer it to production Java.
So yeah, I think Early is bringing up that exact point that I was going to talk about. Is Python is great for prototyping, and that's exactly where academia has been excelling, because it has been it has helped them really quickly bring something to market. Right? They had an idea, they had an hypothesis, had a paper that they wanted to write, and then they expressed that paper in Python libraries. Now, where the problem came was best practices. They started taking those prototypes into production. And those prototypes were not solid and reliable and scalable enough to run in production. And then they continued. And then there's so much work now done that, as Suyash pointed out, look at the engineering costs of trying to put a lot of that Python work into production and trying to bring it at scale, and compared to the same when you did with Java products or Java applications or Java frames, where we already have a tried and tested pipeline that works. Thinking of all those two pathways, Python is not being built to scale or is not being built to production at scale, whereas Java has been. And so converting some of your core work that is expensive in production because of being slow and other reasons into Java would be a good first step.
Okay, so
I have to also go. Maybe we can end it, EL, today here.
Yeah.
If there are any pending questions, unless there aren't any, or if they're going to take us a lot of time to answer, then maybe we could do the last couple of questions and then maybe sign off.
I guess so. What I wanted to say is also this will continue. We will we plan at least to have it about once a month. So whatever question came up today, and maybe you went home and thought about it, or you're watching the video not live and you thought of new questions or wanted to find out more about what we discussed here, bring it back the next time, send it to us, or just bring it with you to the next panel, and we will continue. I hope next time maybe we'll give Zoran will have more time to talk about what he does. We can ask him more questions about that. And I also, some things came up today that look very interesting for people like Tornado VM and maybe more about Growl. Maybe we can get people that do that on a daily basis. Maybe we can get somebody that will sit with us so we can work on that as well. Last thing that I wanted to say is I'm going to put here a link. I invite anybody that is interested to schedule a conversation with me. In this link, you can, I have some time slot open. I like to do that. I want to understand more what people think, what people need. If you have any questions about how to start with Java and AI, how to bring Java into your project, or how to bring a machine learning project into your Java code, anything related to that, I would love to talk to, help you clarify. This is a free service. You're member of my community, or you're all member of the members of the AI. Enterprise AI or AI for Java, etc. And if I don't have good answers, I can say, bring these guys to help me and involve them as well. So please do that if you have any desire to ask questions in person or to get any kind of advice.
I don't think he'll ever get a chance to answer those questions because EL pretty much has many answers, unless he's going to talk about magic, which only Suyash knows among the 4 or 5 of us. And I don't know what my specialty is, but I think you can handle most of the questions.
Well, I was going to suggest that Suyash puts also, he trains the system to recognize his face. So when he holds the cards, it will give the right answer. Somebody else tries, it's not going to.
That's a great idea. That's a great idea. Yeah. Cool. We'll have demos next time, and maybe we can talk about services too and other fun stuff, whatever people want to talk about. I think EL, check out his blog. I think that's a knowledge what's missing, like how to deploy these in production. He's written a Spring app.
Yes, definitely. I would love you to ask questions about the blog or give me suggestions. And any comments, any kind of feedback is greatly appreciated. There is also a survey, but we will get to that survey. I'll send it to you by mail. I think we just lost Suyash. I think we're running out of time. So
somebody has abducted him because it has happened to Adam before. I think the Oracle guys are getting abducted on your show here. Something's going on over there. It's probably brain drain that we don't know. They're using your show to get them, whilst they have them in the open and take them away.
I guess you're safe because you're in England, so it's harder to get to you.
Well, yeah, there's a big pond between me and the rest of the world, so it takes them a while to get here. So.
Okay, so I thank the people who were abducted. I thank you, Mani.
Yeah, thanks, EL, for having me here, and also the others. And I hope the rest of the audience enjoyed this. And if there are any questions, actually, there are 2 questions. Oh. If I can quickly look. Okay, yes, let's talk about vector API support in Java 16 in context of ML. Maybe we could pick this up for our next conversation, because then we would be more prepared. Anyone working on binding for TensorFlow? I think Adam has already answered this question.
Yeah, he did.
Okay, so we can resolve that one. But the one, let's talk about vector API support in Java 16 context of ML. That's a great one because that's kind of bringing us to a Java interrupt with, or not just that. It also talks about bringing NumPy-like operations in the world of Java. So that'll be great too. I'm not fully familiar with how the API works. It's something we could work on. And
I actually saw a presentation this week. Oracle had a short conference, and there was a presentation about Vector API. My impression was that it's a very low-level API. It's not something that you would use in an everyday language.
Right.
Use it to write libraries that will do things faster than they do it now. You re-implement things that were already implemented. That's my shallow impression from watching that.
Is that going to help us do things that Python is now able to do with NumPy and pandas? Because that's something what I understood by Vector API, but maybe I'm just vaguely right here.
I think we as developers or ML developers that want to do the same thing that we do with Python do that with Java. We will not directly do it with the Vector API. We will do it with libraries that will be built on top of that.
Okay, so something like Tribuo or DeepNets would implement something in their...
Somebody will even implement an equivalent to a frame manipulation framework like pandas.
Right.
But Vector API itself is not something that's easy to use. It's very low level. It gives you the power to do that, but you don't directly use that, I think, as a replacement.
That's great. So that's something we could talk about. Prepare ourselves for it next time, and maybe even talk about what Suash brought up, Java interrupt with Python and the different ways, shell interrupt or through Python or through another way like Panama. Maybe something in those lines I could think about. Are we thinking this to happen in 3-4 weeks from now?
Yeah, let's go with that. Let's plan on that. Yeah.
Okay, cool. So I'll leave it to you, Eyal, for you to close this.
Okay, so thank you again, everybody, and hope to see you next time.
See ya. Bye-bye.
Bye-bye.